Welcome to my second video on the physics of string instruments and how knowing a little bit about the physics of the instrument can really help us to become better teachers. If you didn't get to watch my earlier video about Helmholtz and his stick-slip motion and about the sports car lane, the family car lane, and the truck lane, it would be helpful if you watch that first, but not absolutely necessary. The topic of this video is why we get color changes in our tone depending on if we're playing out closer to the fingerboard or closer to the bridge. Before we get to the tone color changes, I would like to discuss how the differences in tension and thickness of our four strings affects how the lanes work, and I would also like to discuss what I call the family car 10% rule. Of course, we all know that there are really an infinite number of lanes between the fingerboard and the bridge, but for simplistic purposes, I'm just saying that there are three lanes. There is the sports car lane out here where the bow travels like a sports car, light, fast, and tipped up on its side. Then there's the family car lane where the bow travels medium speed, medium weight, medium tilt of hair. And then the truck lane where the bow is like a truck, slow and heavy. However, because the G string is looser and fatter, when I'm talking about the sports car lane, let's say that that would be about here. But the D string, a little more tension, it's going to be more like here. And the A string, moving it down a little bit, the E string about there. So there isn't one exact place across all four strings. We have to do a little bit of bow adjustment. Now, if you're playing rapidly back and forth between two strings, there's no time to do a bow adjustment. So we will choose a place that works for both of those. And then for the family car, the same thing is true. So maybe the family car G string is there, D string, A string, E string. And then the most important one is for the truck lane, we really can't play very, very close to the bridge on the G string. And the D string can be a little closer, A string a little closer, E string can be quite close. A minute ago, I was mentioning my family car 10% rule. What that is that if we are playing an open string, let's say the A string, then to play in the family car, basically we're going to be about 10% of the way from the bridge to the nut. So I'm guessing that's about here. That's a good family lane area. Of course, I just said a minute ago that the skinnier and the tighter the strings, the more the lane is slightly closer to the bridge. But in general, we can choose that spot for 10% from the bridge to the nut. So if I were playing my first finger on the A string, B, right here, then ever so slightly my family car could be slightly closer to the bridge. Probably not enough to make a difference. But let's say I took that first finger B and I shifted that finger up to 8th position. I moved it an octave higher, and so now my first finger is about there. In order to retain the same speed and weight and numbers of hairs on that, I need to change the distance from the bridge because I want to now have 10% of the way from the bridge to where the string is stopped. So now my family car lane has moved up to what used to look pretty much like a truck lane. So that is now my new family car lane. For students who are doing shifting, especially intermediate and advanced students who are doing a lot of large shifts, it's important to remind them that the bow has to be part of the shifting process too. For example, here is that B to B shift that I was talking about on the whiteboard. So now on to the color changes. A pitch is made up of the note we're playing, and that's called the fundamental. But it's also made up of other notes that we can't really hear. These notes are called the overtones. It's like when we have a piece of cake. You mostly taste cake. That's like the fundamental, but you also have different flavors that you can't really identify, and those are made up by the individual ingredients like the sugar and the salt and the butter. So how do we find what those overtones are? Well, if we played the fundamental note of D, open D string, we can find those overtones by playing the harmonics that come out of the D string. For example, those are some of the harmonics, and then they go on and on and on. The farther away they get from the fundamental, the higher they get, the harder it is for us to hear them. Another way to hear the overtone series is for me to play a note on the piano, but then to hold down notes with my arms above that, and you'll hear some notes ringing. This is a video of a video called Violin Bowing in Slow Motion that you can watch on YouTube. When the friction of the bow creates the stick-slip motion of the string is no longer a straight line. It now makes a whip-crack motion. The angle of that whip-crack is called the Helmholtz corner. The closer to the bridge the bow is, the greater the force required and the sharper the Helmholtz corner is. In this video, you can see the Helmholtz corner as it travels to the nut and back. The bow is quite close to the bridge, and so the corner is quite sharp. When we play closer to the fingerboard, much less friction is required to get the stick-slip motion. So the Helmholtz corner is a much more gentle corner than close to the bridge. For example, I will play a middle C in the sports car lane. It has a pale tone, but if I play close to the bridge, a lot of friction is required, and so the Helmholtz corner will be much sharper. Let's discover why the tone color changes depending on where we play. Here is a graphic of the middle C that I just played, and then we can see the harmonic mixture of the overtones inside that middle C. So we have the first couple overtones are very strong, and then as it goes through the overtone series to the higher overtones, they actually get softer. That is for when we are playing close to the fingerboard. The high overtones are not very loud at all. But when we look at the graphic of the harmonic mixture when we are playing closer to the bridge, we see that the higher up overtones here are much louder than they were in the fingerboard version. So look at the E7 here. This is the fingerboard version, and the C7, not very loud, but over here we have the C7 is incredibly loud, and the E7 is also quite loud. The F7 on the fingerboard version doesn't even rate, but here the F7 is up this high. So when we are bowing with a sharper Helmholtz corner, those upper overtones are activated, and that creates the more penetrating, rich, soloistic sound. Thank you for watching this video on the 10% rule, Helmholtz corner, color changes, and overtones. Please check back for more videos if you're interested in string instrument physics.